Please welcome to the stage, Martin Beebe.
Now I'm looking at a room of people looking at me and thinking that something's amiss. I am neither Dutch nor Werner Vogels. And I'm afraid that's because this morning, Werner called me and said, Martin, I'm feeling very ill, and I don't think that I can go on stage today and give this talk. So I'm afraid that Werner won't be here today. Yeah. But I'm here. Yeah, and you guys are going to be with me, and we're going to do a keynote a little bit different in my style, but it's roughly what Werner was going to say anyway. You know, AWS is a very resilient company. All of our services are very resilient. You know, we have backups on the backups. You can think of me as a sort of Werner Vogel's availability zone, you know. But thank you very much for coming. It's brilliant to be in New York. This is the second time that I've come to New York. Last time in 2019, I think we were all together in this very room. I actually did a small 10-minute segment in Werner's keynote. So it's a kind of a rehearsal almost to this one. But it's wonderful to have everyone back again, you know, after what we've been through. And I'm super excited to be in New York. And I've got a few days in New York to explore. So if anyone's got any recommendations, do hit me on Twitter and tell me what I should do in New York over the next 2 days. Summits are a wonderful thing. I get to, in my job, go to pretty much every summit all over the world. We go to Australia, to London, where I'm from, Amsterdam, and places like New York, across America. And the brilliant thing about these summits is the ability to learn new things and explore new things. And I implore you all, when you're at this summit, take advantage of all that's on offer, all the workshops, the breakout sessions, read the case studies that we put out there, visit our sponsor stands in the expo hall, and really start to discuss with peers and people which are doing big and impressive things on AWS and learn what they're doing, share your own experiences with people, because that's why we're all here to be together. Now, AWS has come a long way from its first region in North Virginia in 2006 when we were running sort of services like S3 and EC2. That first region, we then started expanding with a second region in Ireland in 2008. This is kind of providing people with the backup capability, the sort of resiliency again, but also like lowering the latency for some of our European customers. As we started sort of building on this, we've now got to a situation where we have over 84 availability zones across 26 geographical regions. It's a really big global footprint that AWS now has. It's the most extensive global footprint of any cloud provider. And we're continuing to grow new regions and add new regions as customers request them. And we have 8 more regions coming in: Australia, Canada, India, Israel, New Zealand, Spain, Switzerland, and the UAE. We've got 24 new availability zones which are planned coming to kind of help you build applications which span the globe. Now, when we try and build what we're building with AWS, we're trying to do that in a sustainable way. Everything we do, we think about the sort of impact to the climate. We're actually the co-founder of the Climate Pledge in 2019. And we're hoping to power our operations with 100% renewable energy by 2030. And we're very much on the path to achieving this ahead of schedule by 2025. So Amazon is now the largest corporate purchaser of renewable energy in the world. We have nearly 16 gigawatts of energy in our portfolio, and that comes from over 300 solar and wind projects across 19 countries. And the scale and innovation that we have at AWS means that we can achieve really higher resource utilization than most people can achieve on their own. Some research by a company called 451 Research showed that AWS is 3.6 times more energy efficient than the average US enterprise data center. And that running applications on AWS instead of inside on-premise data centers could reduce associated energy costs by up to 80%. So just by using AWS and moving to AWS, you're likely improving your carbon footprint and your sustainability. Now, when I speak to customers, you know, at events like this, at summits around the world, and in meetings and so forth, I ask them, well, why do they pick AWS? And obviously, there's the big ones, the things that we've always been well known for, things like the agility, cost, and elasticity. But then there's other things like security. We can provide all of our services have security baked in. It's something we think about deeply. Often we can help improve the security posture of our customers just by adopting AWS. But the other real big thing, and I think it attracts a lot of people to AWS, is just the pace of innovation. Now, you may hear us say this before, but 90% of what we build, the services and features that we create at AWS, are built because customers tell us what they want. They explicitly ask us for things. They want a new feature or a new service, or they're telling us a problem. And 90% of what we build comes from just that, speaking to customers. We are a customer-obsessed company. And the other 10% comes from us inventing on customers' behalf. They might not exactly articulate precisely what they want, but we kind of think forward for them. We invent on their behalf. In 2001, we had over 3,084 services and significant features launched. And the reason I mention innovation is when you're choosing cloud providers, it's really important to think about how innovative they are. Because tomorrow's challenges will be different from today's. And you want to choose and bet on a cloud that's going to innovate on your behalf and constantly innovate for you. So you want to choose a cloud provider that's best for you now and best for you in the future. Because it's still day one. Still day one for all of us. We're very at the early days of cloud. We've still got a long way to go. We've got lots of innovations ahead of us. And yes, we've been an extraordinary innovative company over our history, but the next 10 years, the next 15 years, the next 20 years, we're going to do things that we can't even imagine today. Now, when you pick the cloud provider, or when you're thinking about the IT decisions, it's really important that you choose carefully. Because decisions that you make today can be with you for a really long time. And it reminds me of a story that I heard about spaceships. On the side of these spaceships, you'll see 2 solid rocket boosters. Now, to generate thrust on a space shuttle like this, you want those rocket boosters to be as wide as possible. But you can't just infinitely increase the width, even though if you could, you would increase the amount of thrust, because there's a surprising limitation to the size of those boosters. And that limitation is that those rocket boosters have to travel to the launch site via train. And when they go through trains, those trains have to go through tunnels. And the US government have a restriction on the size of freight that can go through those tunnels. It's got a maximum width of 13 feet. Now, that means that you have a limitation of how big those booster rockets can be, because the only way to transport them really in the US is via train. So those tunnels, which are 30 feet, that restriction is kind of related to the size of the actual tracks. And those tracks, they have a spacing of 4 feet, 8.5 inches. Now that number seems kind of random, but it actually was inherited from the British when they built the first railroads in England. And that size, those first railroads were built to the same width that was used for building wagons. And wagons were built to roll on the roads that were first made for the wheels of Roman war chariots. Now the chariots, they were standardized to accommodate the width of 2 war horses, which so happens to be 4 feet, 8.5 inches. And I guess the point of saying all of this is that a significant design feature of a shuttle was influenced by the width of 2 horses 2,000 years ago. Decisions that you make in the past stick with you for a long time in lots of interesting ways. Business constraints can date back to decisions you made years before. When you make decisions about the cloud today, you want to make the right ones. Those decisions will have long-term impact on what you're able to achieve. And I'd encourage you all to choose the most innovative cloud, because you don't know what the future holds. It's not necessarily the same as today. You need someone which is going to innovate and constantly give you options for the way that you build your applications. And that's what we try and do at AWS. Continuous innovation on your behalf. And it's not always innovation that you can see. Not innovation that is a new feature or a new service. It's often the way that we run those services under the hood. And a great example of how we do that is the AWS Nitro system. And with the Nitro system, we really reinvented the way that virtualization works. Now, early virtualization at AWS was based upon the Xen hypervisor. Now, the Xen hypervisor is a software hypervisor, which we pushed that kind of concept of virtualization to its absolute limits, really. On a classic, in this idea of a classic sort of virtualization, you would have a privileged virtual machine, effectively, on the host server, and that would then communicate with all of the devices on that server. So being able to share it amongst all the virtual machines which are virtualized on that host. But this kind of brings a lot of problems, really, because you have this virtual machine, which is kind of privileged, which is being accessed by all these virtual machines. There's a big surface area for attack, really, from a security point of view. And also, you have all these virtual machines which are sort of routing requests to speak to devices and all of that stuff through this DOM0 virtual machine, and we have them fighting for the same resources. We call that I/O virtualization attacks. And what you find is that you get a lot of, especially on things like the network, when there's all these virtual machines sort of requesting access to the network, in traditional virtualization, you end up with lots of jitter, and there's a big constraint about the throughput you can get through the network. So we thought about this problem. We thought, well, how do we change this? How do we improve the way that we do virtualization for our customers? So what we did is we worked for a very long time and developed this, what we now call the AWS Nitro system. Now, Nitro is a new way of doing virtualization. Was a new way of doing virtualization. It was revolutionary, in fact. And it offloads a lot of the virtualization work which was previously done in the hypervisor, the Xen hypervisor, onto dedicated hardware and some thin layers of software. We still have a hypervisor there. But most of the virtualization is now happening in hardware, dedicated hardware, which is designed specifically for that purpose. And this improves performance dramatically, but it also is more secure. We no longer need that privileged virtual machine, the DOM0 machine, to kind of manage the instructions. We can now do that all in hardware. We can do things like encryption a lot more performantly, and generally improve the security posture of the virtual machine. So physically, if we looked at a server, you have a physical card, like a physical card on that machine, which we call the Nitro controller card. And this is where the AWS code runs that manages and makes that server, effectively, into something which can run EC2 instances. Because we're doing a lot of the processing on these cards, on the controller cards and the cards which it talks to, we're kind of offloading the work from software, which has to use the CPU and memory of the machine, onto dedicated hardware. So we're giving back the full power of the machine to our customers, where they can run their instances. And Nitro makes it very easy for us to now take any kind of machine and turn that into a server which is capable of running sort of EC2 instances. So that Nitro controller card, that communicates with a bunch of other physical Nitro cards and the Nitro hypervisor. Nitro cards include Virtual Private Cloud, VPC. We've got one for EBS and one for instant storage. Now, the hypervisor, which it communicates with, is very minimal. It's got a very small surface area. And it's only able to work with Memory Management Unit and the OS memory managers. It's very small, very minimal compared to what we had before as a hypervisor. The vast majority of work's now happening in hardware. So virtualization is happening separately from instances that are running on that server. Our code is actually running on those cards. So one of the advantages of that is our code can't inadvertently interfere with your virtual machines. It's separated. It's physically separated from your workloads. We don't share the CPU cores or memory between VMs, so there's no crosstalk. And everything is implemented minimally, because we don't want to have the sort of risk of unintentional large surface areas. Nitro's improved the security, cost and performance in a number of ways. And there's like lots and lots of ways. You can look at all this, lots of different features that we've released over the years and say, well, Nitro's actually got some involvement in making that happen. But we also have specific features as well, and one which I like to talk about is Nitro enclaves. And this technology has allowed developers to protect highly sensitive data during data processing, and it's really been enabled by the way that we implemented Nitro and the flexibility that Nitro gives us. So if you have a parent EC2 instance, you can run a command to launch what we call an enclave. And you will, in the API call, you specify the CPU you want, the memory size you want for your enclave. And those resources are reclaimed from the instance that you have. The Nitro hypervisor is actually doing this, and it's working with the underlying OSs inside of the instance types to use things like, to use the hardware not unplugged feature of Linux or Windows, so that it will basically take the resources from the parent instance and create a new peer VM, which is separate to the original instance. That new VM that's being created is what we call the enclave, effectively. And that is different to the parent instance in a number of different ways. First, that enclave has absolutely no connectivity to the internet, no IP connectivity. It has no persistent storage, effectively. It's isolated. In fact, the only way that it can really communicate is via the parent instance over a VM socket or a vSock. Now, inside the enclave, you can write any kind of application that you want, in any programming language that you want, using any kind of framework. And what you would maybe do in some of these sort of enclaves is you would be maybe wanting to process sensitive data, highly confidential data, and you do it in this enclave because you don't want to for some reason you don't want to be any of that code to escape or anyone to be able to inspect or look at that data as it's being processed. So you process that using whatever framework, whatever language you want inside the enclave. This enclave has no connectivity apart from back to the actual parent instance. And what that means is that we have a system called the Nitro Acetation process. And this process verifies the integrity of the hardware and software of the host. So when we launch that enclave for you, we checksum it, and as it's booting, and at any time, the enclave can ask the Nitro Acetation process for cryptographic proof that that enclave is who it says it is. That is the enclave, only that enclave. And this proof can be provided to other services, including our key management service, KMS. And this can be used to release key and secret material to the enclave, and only to the enclave. So if you can imagine writing an application inside that enclave, which is going to process some data, well, the data can remain encrypted all the way into the enclave, and then once in the enclave, you can take the key or the secret to unencrypt that data, do the processing that you want, get the result that you need, re-encrypt the data, and maybe pass the results back out over the vSocket. So it means that outside of the enclave, the data's never been unencrypted. It's always encrypted. And the only thing that can actually get the key data to unencrypt the data is the enclave itself. The parent instance doesn't have access to the key because of the Nitro Acetation process, which defines that only this particular enclave is allowed that key information. So with these sort of under the hood sort of capabilities, we're able to offer you services so that you can process very highly confidential, sensitive data, knowing that only your enclave will be able to see the actual data and process that data in a very, very secure environment. That's one example of the many thousands of things at AWS that Nitro's enabled. Nitro's really changed the way we control our compute environments. It's made us be more agile, because Nitro's modular. We can build and construct new EC2 instances using the Nitro system in ways that just was much harder for us to do before. And we can reuse those Nitro components across different types of EC2 instances and build a growing variety of systems. We now have over 500 instance types that are generally available, and it's more than any other cloud provider. And you can find the right instance type for the particular workload that you want to do, what you want to run. And Nitro's really been at the root of how that's even possible for us. It's enabled us to build things like bare metal instances. It's enabled us to run Mac and Mac M1 in the cloud, and Mac M1 which just this week became generally available, and do ultra clusters for HPC, all these kinds of new instance types, allowing us to build any kind of application. It's all becoming possible. And not just, innovation doesn't just happen and stop in one place and on one instance. It happens all over the place. The way that we approach silicon is also very innovative. We have the largest choice of processors. We have the latest Intel Xeon Scalable processors and the latest AMD EPYC processors. But we've also been developing our own custom silicon. Whenever we're building our chips and our silicon, I think one of the things that's really top of our mind is sustainability. Like, how can we make these processes more efficient? And we've improved efficiency in these processes by really sort of developing and thinking about the underlying technology and how we build these. We actually purchased, acquired a company called Annapurna Labs, and they're now helping, well, they're part of AWS who build our silicon, build the silicon which actually goes into our EC2 instances. And we have all different types of these processor options, and we have Terranium, which has been designed for developing deep learning models. We have Inferentia, it's designed to accelerate deep learning workloads once they're deployed. It's our most power-efficient inference processor. And that brings us to Graviton, which is really a piece of silicon or a chip which you can run all sorts of workloads. It's more of a general purpose kind of workload thing. And a lot of applications that you're running today, which are running on different processor types, you could probably run on Graviton. We saw in 2021 tens of thousands of customers take advantage of Graviton. Graviton, we had, it improved the performance that we could get from our processors. And in 2021, we launched the Graviton 3 processor. We're now our third generation of processor. And it provides up to 25% better compute performance compared to Graviton 2. They also use up to 60% less energy for the same performance as other comparable EC2 instances. Now, when I talk about Graviton and silicon, you might be thinking, well, that's great if you're using EC2 instances. I could just start up a new EC2 instance, start using Graviton. But maybe you're using a managed service from us. But we've also released Graviton-powered versions of our most popular managed services like EMR, Amazon OpenSearch Service, and RDS. And you might be thinking, well, I'm not even using managed services. I'm actually using serverless. I'm using something like Fargate or Lambda. But we have Graviton support now for those as well. And with Lambda, just by switching your tasks to Graviton, your functions to Graviton, you can see up to 35% better price performance. So I really think that from a cost saving, but also from a sustainability perspective, you should really start considering serverless and how you use serverless when you're designing your applications. Moving to an event-driven architecture, it really helps you maximize your overall resource utilization. And so if you're not using serverless today, and you've just heard it maybe as more of a buzzword, or speak to people today at this summit. Learn more about it, because it genuinely could save you money, and it also could help us, sounds a little bit grand, help us save the planet. If you're interested in how you build applications with sustainability in mind, look at our well-architected framework. We have a whole sustainability pillar which describes ways that you can be more sustainable with your application development. And it will describe as well how you build serverless applications and architect them well. So Nitro and Graviton, they're just two innovations that make AWS the best cloud for all applications. But AWS is not just for born-in-the-cloud applications. It's also for the things that we all have to run, we all have to manage. It's things like SAP, Oracle, and Windows as well. You can run all those kinds of applications on AWS. And it's increasingly for latency-sensitive workloads. Workloads that might even not need to be in a region. They might not need that compute resource might need to be closer to where you are, where your office is, where your factory is. And increasingly, we're seeing us innovate at AWS in ways to try and make the cloud come closer to our customers. We like to think about pushing the edge of the cloud. We have our AWS regions, with our availability zones and so forth, where most of our services work, and I'm sure that many of you have applications deployed into our regions. But we also have things like our edge locations, like CloudFront, all the points of presence which are globally distributed, and services like AWS Lambda Edge, which allow you to move the caching or some of the service or compute a little bit closer to where your customers are or where you are. But we also have this whole array of services now, which are really sort of embodying this idea of pushing the edge of the cloud. And it's giving customers a spectrum of choice on where they want to run their applications. One of these is AWS Local Zones. It provides compute and storage, so database and a select number of AWS services. It's close to large populations in industrial centers. Local zones enable you to build applications that require single-digit millisecond latency. And we have 17 local zones across the US, and there's new local zones coming. We've got across 32 different cities across the globe, which will allow you to build these low-latency applications closer to your customers, not just in the US, but globally. So one customer which is using local zones is Supercell. Supercell are a Finnish-based mobile game developer. If you've ever played Clash of Clans, these are the people which build that game. They have hundreds of millions of active users. They have hundreds of databases, thousands of servers, and produce terabytes of data, all on AWS every single day. And Supercell, they use AWS local zones in the US currently to bring the real-time and latency-sensitive portions of their gameplay and the service closer to the end users which are playing that game, so that they get more responsive games and they're able to build more immersive games for their customers. And Supercell are really interested as we expand these local zones. They're looking at where we're bringing those local zones so they can bring those latency numbers down for their customers globally, not just the ones in the US. Now, speaking of low latency as well, we also have AWS Outposts. Now, AWS Outpost is a fully managed kind of hardware offering, which is delivering AWS infrastructure and services to any on-premise location. You might think of AWS Outposts as these big sort of racks of servers, but we actually have a 1U and 2U options as well, which means that you can actually bring Outposts and AWS services to places like factories and retail locations so that you can run applications closer to where you might need to process them. So if you have latency-sensitive applications, mission-critical applications, you can start using things like Outposts, but using the same AWS services, using the same APIs, the feeling of developing against AWS, but you're actually developing against an Outpost, which in turn is connected to a region, is fully managed for you, just like the regular cloud is, but it's bringing that closer to your customers and enabling you to build new kinds of applications. AWS Outpost is enabling the migration of Nasdaq's North American markets to the AWS cloud. They're going to be using Outposts to provide ultra-low latency edge compute capabilities directly in their primary data center. And this Nasdaq story just really highlights this trend. AWS bringing these services closer to our customers so they can bring their mission-critical applications to AWS. Now, I've only touched on a couple of local hosts and local zones and Outposts, but we have this array of services. We have AWS Wavelength, which enables AWS compute and storage services within the edge of telcos' 5G networks. We've got IoT services, which connect the billions of devices that improve our lives. And we have the Snow family devices, which are physical devices that are used for storage, but importantly as well, they're able to run compute on these small Snow devices. Now, if you've not seen Snow devices, we have a range of them. But my favorite one is this snow cone. And recently, we put one of these with Oxum. We worked together, and we integrated this into the International Space Station. What's cool about this is once that snow cone is in the space station, our teams at AWS are able to communicate remotely with that snow cone device and run AWS machine learning at the edge. This helped the team to quickly process, tag, and analyze photographs of onboard research experiments. Now, this experiment successfully demonstrated some of the storage, compute, and machine learning capabilities that are possible in low Earth orbit using existing AWS technology. It kind of blows my mind that you can put when I saw this picture for the first time, it was like, wow, that's something in space. That's compute. That's AWS in space, closer to our customers. Now, these services are supported by the AWS Global Network. And this network spans the globe. A fully redundant 100 gigabit per second global network carrying traffic between 26 regions, 84 availability zones, and over 410 points of presence. All the traffic which traverses the AWS backbone is encrypted. And when you're a global company, you need to have this global network. It's critically important so that you can run your applications on our network at low latency, at the speed that you want. And today, I'm excited to announce the general availability of AWS Cloud WAN. Woo! Come on, people, that's yes! That's a service to build, manage, and monitor global wide area networks. Now, Cloud WAN uses this AWS Global Network to connect your on-premise data centers, your branch offices, and cloud resources to AWS. And Cloud WAN makes it easy to increase your network security and gives you one console to manage everything. Now, to talk about how this kind of, the innovation that we're building and the infrastructure that we're building, how it helps our customers, I'd like to introduce a customer who's using this AWS next generation infrastructure to pioneer new capabilities in observability software. She's a well-known visionary and expert in site reliability, engineering, as well as an AWS community builder. So please welcome Liz Fong-Jones, Principal Developer Advocate at Honeycomb.
Hello, everyone. I hope you are having a wonderful AWS Summit. And tonight, when you go home, I hope that you get to have a nice, peaceful night of sleep afterwards, having learned a whole bunch. But what if there's a problem? What if your pager goes off 20 minutes before you want to be in bed? How are you going to feel? Are you going to feel anxious? Are you going to feel nervous? Or are you going to feel confident that you got this and you're going to be able to solve it within half an hour and get back to sleep? This is what we're about at Honeycomb. We're about helping software engineers like yourselves debug their systems with the power of big data. This capability is something that we pioneered and call observability. Observability is a socio-technical capability. It's something that really enables us to answer any question about our systems, even ones that we hadn't thought in advance to ask. It requires us to add data and collect it and store it economically, and then to query it as quickly as possible when you need it the most. And what do I mean by as quickly as possible? I mean, you should be able to answer any question in less than 10 seconds so you don't get distracted by going to get a cup of coffee, and so that you can keep on iterating on your train of thought. We think that observability requires having as much context as possible, and to have all of that context connected together, threaded together into user requests that are traced through so that you can follow the breadcrumbs. And we believe that you need to be able to analyze all kinds of customer experiences, good and bad, so that you can figure out what is differentiating those and how can you resolve the issue as quickly as possible. So our product is differentiated by its scale and speed. Our customers get a lot of value out of us when they're able to quickly and instantly get results. And analysts agree that we're a leader in the field of APM and observability. So how does this actually work under the hood? It starts with high-quality telemetry data, which we collect in partnership with AWS. Using services like the Relational Database Service, or CloudWatch, or any number of services that we integrate with in the AWS ecosystem, we're able to get data at the low level. But it's also crucially important to have telemetry that is collected, for instance, with the Amazon distro for OpenTelemetry, that comes from your applications and your real user requests. Once we have that data ingested, we're able to go ahead and analyze it and store it. So we pre-process it and upload it to Amazon Simple Storage Service, and then we're able to analyze it on the fly with AWS Lambda. So over the past 10 years, Honeycomb has grown really explosively. How explosively? Well, 3 years ago, we were ingesting about 200,000 trace spans per second. Today, we are peaking at 2.5 million trace spans per second. And our customers are asking 10 times as many questions about 10 times as much data. You can see where this is going, right? So how did we scale our services economically? And oh, did I mention, we only have 50 engineers. The answer is we built on the right AWS technologies. So this is what our architecture looks like. We have a combination of stateful and stateless services, and they're mostly written in Go, but you'll also find some Java and some Node.js running in our stack. But all of these were able to be migrated on to AWS Graviton technologies. So let's start with the stateless technologies. So we use Amazon Elastic Kubernetes Service to manage our stateless workload. And the nodes that are powering it are EC2, C6G, and C7G instances, powered by Graviton2 and Graviton3. So let's take our ingest service, for instance. When we trialed moving from 5th generation EC2 instances to Graviton2, we saw a 10% improvement in the median latency, that we were having many fewer tail latency spikes because the Graviton2 processor is just much more efficient. And we were able to push much more load. But it gets better, because when we did an A/B test of Graviton2 versus Graviton3, we found a further 10 to 20% improvement in tail latency and a 30% improvement in our throughput and median latency of our ingest services. And not only that, it turns out that this workload just bin packs much better with EKS and Graviton3, that the CPU utilization is about 30% lower, which means we can push it a lot harder. And it turns out that you can compound this savings by using EC2 Spot instances, because the node termination handler in EKS allows you to just gracefully fail workloads over as EC2 Spot terminates the instances. So we save money by being flexible. How does that work? Well, it turns out that when we went from 5th generation to 6th generation, we saved about 20%, and then we saved a further 20% when we adopted 6th generation instances powered by Graviton2 with Spot. Our columnar data storage is powered by EC2 M6GD instances. When we switched from the i3 instance family to the M6GD instance family, tail latency went down by 2/3. And also, we tier data over to S3, and I'll talk about that in a moment. So speaking of other data storage mechanisms, we use EC2 IM4GN instances to power our Kafka streaming data ingest. And these instances were newly announced at reInvent this past year, and they're powered by Nitro SSD. So we had a problem before, that we didn't have the right shape to scale with our workload, where we stream data, and we need to make sure that we get it right the first time, but we don't necessarily access the older data until there's an emergency. So we were disk-bound, running 30 instances of i3 EN. We started tiering the data to S3, which helped, but then we saturated it in CPU. But right-sizing everything onto IM4GN lets us hit our network, CPU, and storage thresholds appropriately. OK, so about the query retrieval. How do we make it fast? Well, one answer is just use more M6GD, right? That only works up to a point, because if you have millions of files stored in S3, you're going to have a hard time querying them all from even just 100 servers. So we utilize AWS Lambda in order to query on demand millions of files from S3 with tens of thousands of parallel workers, which allows us to give you results for any question you might ask about your systems in less than 10 seconds. And with AWS Lambda and Graviton combined together, we see about a 40% improvement in price performance, which really enables us to economically give our users the comfort of knowing they're going to be able to get a great night's sleep. So to sum up, AWS enables us to go fast. With AWS, we're able to build quickly and help our customers move quickly too. We've saved over 60% versus fifth-generation instances. And also, as you heard earlier, we also have 60% reduction in emissions from using Graviton 2 and Graviton 3. So we've scaled 10x over the past 3 years without blowing our SLOs and without blowing our cost budgets. If you're interested in learning more, you can check out the chapter of observability engineering on our data store. And you can go and get all of the meaty technical blogs and details at the link that's on screen right now. So now I'll go ahead and turn things back over to Martin. Thank you very much.
Thank you very much, Liz. So systems generate massive amounts of data. The cloud has really just changed the way that we do business, the way that we can store just vast amounts of information. We can process vast amounts of information as well. And it's allowed customers to build things that they just previously wouldn't have been able to build. Now, most of you in this audience are probably storing terabytes, if not petabytes, of data. And when I say sort of massive amounts of data that people are processing, I really mean it. IDC forecast that there will be over 97 zettabytes of data created and replicated in 2022 alone. And it's hard to even imagine, like, how much is a zettabyte? How many is 97 zettabytes? So to put that into perspective, if you were to save all of that zettabytes onto conventional 1 terabyte hard drives, and you would stack them, one on top of each other, the stack would rise up to the height of the Empire State Building 13 million times over. It's just an enormous amount of data, an incomprehensible amount of data that we're all creating, replicating, and sharing around the world. Now, for those building applications and generating lots of this data, you have to start thinking about what are we going to do with this data? What's our data strategy? And when you're developing a data strategy, you have to think about a few things. To get data or value from all of this data, we want to try to become a more data-driven organization. And lots of customers that I speak to talk about this. They want to become more data-driven. They want to make higher, faster quality decisions with their data. And really, to do that, you have to develop a good data strategy. Now, a data strategy has to be many things. It has to be scalable. It needs to be flexible to support any kinds of workloads that you have today and in the future. And of course, it has to be secure. That's like job zero for like day one. That's the first job that we think about AWS. And I'm sure when you're thinking about your data, it has to be secure. We have to think about security every single level. But there's also many others. And this is not a complete thing that you have to think. There's tons of things that you have to consider with a data strategy. But things like governance, who has access to the data, making sure people have access to the right level of data at the right time. And it must be available so that they're able to utilize it, to access this data, to analyze this data. And of course, we've got to store it cost effectively as well. So when you're trying to think about building a data strategy, at AWS, when we explain this to customers and we talk to customers, we like to think about it across 3 strategic pillars: modernize, unify, and innovate. So first, modernize. It's by moving that data infrastructure can help you scale, moving to modern data infrastructure, which can help you scale, reduce your costs, and ultimately reduce those operational burdens. The next pillar is to unify that data, use that data and think about the governance and bring it all together with correct access control mechanisms so that people are able to access it. And then finally, once you've unified that data so it's accessible to people with the right governance embedded, thinking about how we then innovate on top of that data with analytics, with machine learning. So let's take a little bit of a closer look at that first pillar, modernize. Modernizing your data infrastructure allows you to remove a lot of the undifferentiated heavy lifting, the things like database provisioning, patching, configuration, or backups. By moving to modern AWS services, you're kind of removing a lot of that operational burden and modernizing on new infrastructure. When we looked back to that tunnel and that decision earlier in the talk, and we said that that was a constraint that was placed upon us from a decision made over 2,000 years ago. Well, often a constraint that many of us face as application developers is the database choices that we made many years ago. And often it's about the database choice, the relational database choice that you may have made a number of years ago. And you'll have seen this in your careers, I'm sure, of where you made a decision to choose a certain kind of database, and you kind of then just use it for everything. I'm a .NET kind of developer, and I often reach to SQL as a database regardless of the problem. It's my solution to any kind of database problem because it's kind of what I know best. When all you have is a hammer, every problem looks like a nail. So making sure that you have the right thing, the right infrastructure to manage your data is important. And thinking outside of the box, thinking outside of things that maybe you're comfortable with, and looking into new options. And that's one of the great things about AWS. We have a broad array of services, and we've got a huge portfolio of database options for you so that you can start to modernize your databases and your application storage. So you have things like DynamoDB, RDS, Elasticache, Neptune, and I'm not going to go into all of these different kinds of databases, but I encourage you when you're at the summit, think about that. Think about, are relational databases necessarily the best choice for me? Could I be using a graph database? Could I be using, maybe a relational database, but using RDS to take away some of the operational burden? Think about really how you manage that infrastructure and what's the best way to do that going forward, making sure that we don't get constrained by the decisions that we've made many years ago. Now, moving to a different database can be really daunting. But we do provide tools. We have the AWS Schema Conversion tool and the AWS Database Migration Service. And this really bundles our knowledge of migration and the best practices of migration to enable you to easily migrate your databases from wherever they are at the moment to AWS, but also thinking about maybe migrating them across different types of database. So supporting migrations from one database to another, but also to different database platforms as well. And to date, we've helped customers migrate over 625,000 databases using the AWS Migration Service. It's not all about database, obviously, data storage. There's also, we're thinking about how you actually store other kinds of stuff, your object, block, and file storage. And we have a number of different services that you can use to help with that storage, to help with that side of data. So obviously we have S3, our most famous service perhaps, and the oldest running service for object storage. The service that I think I'm most impressed with at AWS has always been S3. How they do it, how they get to 11 nines of durability, how they manage to create a system which is so easy to retrieve information so quickly. It kind of blows my mind. From an engineering point of view, it's incredible, but also just from a usability point of view, being able to store that information is just an incredible feat. We have EBS for it's obviously easy to use high-performance block storage at any scale, and then we also have FSX and EFS, which allow you to add remove files without needing to manage or provision underlying infrastructure. So they've got lots of different ways that you can store, lots of different storage options for you on AWS. And we also have disaster recovery options. And if you want to move your data from wherever it currently is, in your offices to AWS, we have ways that you can migrate that data and move that data. Some of those physical hardwares, like the snow cone that we talked about, we can ship you one of those and you can start shipping data through to AWS. And we have lots of different things like AWS Data Sync, which allows you to synchronize that data up to AWS as well. So once you have migrated to some of these newer services and modernized the data infrastructure that you sit upon, then think about how do we unify that data? How do we create a single source of truth that can be used to make decisions quickly? Now, data in an organization is spread along lots of different places. It's siloed in lots of different places. It can be, in databases. It could be on-prem. It's in data engines. It's in logs. It's in apps. It's in data lakes, which are around the place as well. it might even be the data that you want to use and access might actually be provided by a third-party data source that you want to integrate somehow. Maybe you want to use something from some of the data services that we allow you to purchase, so you're able to purchase data. Maybe you want to use that third-party data inside your applications. And so to kind of discover this data and to unify it and to use all of this data, you need to really know where that data is. You need to be able to catalog that data so that we can navigate it, so that we can begin to query it. We need to think about how we govern that data so that you can detect sensitive information, protect sensitive information. And you need to be able to run, once you've unified that data, you need to be able to set a way of being able to query that data and run queries across all of that data. Now, lots of our customers are looking at data lakes as a way of sort of collecting all of this disparate information and bringing it into a single place where they can start making decisions faster with their data. Now, customers are building data lakes on AWS, allowing them to gain deeper and faster insights on their data. Data lakes allow you to store all kinds of relational, non-relational, structured and unstructured data at cost effectively. And some of our largest customers are managing exabyte scale data lakes. Now, data lakes are quite difficult to build, and so we have services like AWS Lake Formation, which allows you to take data that you might have, which we bring and store into AWS, into Amazon S3, sorry, and then you can use services like AWS Glue, which is our fully serverless data integration service that lets you discover, prepare, and integrate all of your data. And finally, we have Athena, which we can then use to query that data and kind of gain insights very quickly from that information. So you can start getting real value from that unified data. One of our customers which is building data lakes on AWS is Salesforce. They build their customer data platform or data lake on top of AWS, sorry. And they're able to, what this allows them to do is that they're able to move into regions in a matter of weeks. They're able to access new markets much more quickly than they were able to before, in weeks rather than potentially sometimes it would take them years to launch new regions. So really speeding up the way that they can build and move and service their customers globally. They use lots of our different storage classes in S3, including S3 Glacier, for their hot and cold storage, so they can store that cost effectively, even at exabyte scale. Now, once we've kind of modernized the infrastructure that our data sits on, and we've unified that data so that we can start to query it, and we can start to find it, and we can start to catalog it, then comes the opportunity for us to be able to start innovating with that data. We can start to create new experiences, reimagine old processes. And at AWS, we have the most complete and broadest set of analytics, AI, and ML services for you to use and you to get insights to get insights from your data. These are all the AWS analytics services. We have purpose-built analytics services for all kinds of needs and all requirements. So to search and analyze log data, you could use Amazon Open Search Services. For real-time processing of streaming data, you could use Kinesis or managed streaming for Apache Kafka. For structured data, when you need fast querying, there's Amazon Redshift with up to 3 times better price performance than other cloud providers. And Redshift is always innovating. And today I'm excited to announce 2 new features that they've launched. We have row-level security for Redshift tables. It helps you secure sensitive data in your data warehouse. It provides a simplified process for designing and implementing access policies. You can define a user or a role's access to a specific records of data within a table. And also we have automated materialized views. Now, materialized views have been available in Redshift for a while now, and it allows customers to reduce the latency, the query execution time, so they can run queries faster by doing computation ahead of time and creating these materialized views. Well, now with automated materialized views, what we've done is we've created or helped create these with machine learning on your behalf, so that automatically under the hood, it's creating materialized views to reduce the query latency and execute your queries faster. But that's not all. Redshift are constantly thinking of new ways that they can help their customers and help customers to get insights from their data, and to remove some of that that burden of operating analytics services. And so today, I'm excited to announce the GA of Amazon Redshift Serverless. Thank you very much. It automatically and intelligently scales your data warehouse capacity through machine learning-based workload management, virtually unlimited concurrent users and concurrent queries with consistently fast query performance. You're only paying for the capacity that you use. This is a serverless service. And it's really making Redshift just easier to use and easier to manage for you. So if you've not tried Redshift already, please do go and check it out today. And it joins a number of our analytics services, which are already serverless as well. You're no longer having to configure or scale or provision capacity. And this really helps customers like you focus on what you do best, your business, running your business, managing your applications. We take care of all that undifferentiated heavy lifting for you. We take care of the rest. Now, we also have analytics services which are designed not just for, for line of business end users. And one of those is Amazon QuickSight. We built it in 2016 from the ground up to take advantage of the cloud. It's a browser-based service. You log in and you can start directly looking at your data and looking at dashboards and those sorts of things. And there's no lengthy patching or update cycles because it's a service which you just access through your browser. And there's a feature of that called Amazon QuickSight Q, which is really cool because it allows you to query in plain English. So you could ask questions about your data, such as show me the monthly sales for Americas versus EMEA, or show me year-to-date sales for EMEA versus EMEA by year. No fiddling with dashboards, controls, or calculations. You're just getting the answers that you need in seconds. Now, one customer which is really using analytics and machine learning to reinvent their business of motorsports is F1. Let's take a look.
AWS and F1 partnered in 2018, and since then have helped to cement Formula One as the most technologically driven sport on the planet.
And it's lights out and away we go!
We were able to consider the huge amount of data that was available to Formula One that up until this point, it hadn't really tapped into. How do we present the data to engage the fan more? It was a fairly simple premise on which we built the strategy. F1 Insights are data widgets. It helps the fan to be able to understand at a more detailed level what's going on in a Formula One race. They're a game changer because until this point, there was no way of really understanding all of the details of a Formula One race. We asked the fans what they wanted. They wanted up-close, wheel-to-wheel racing. And that wasn't possible with the current generation of cars. So we had to go away and we had to redesign that car. We needed a technology partner like AWS who helped us to put that whole project together, and hence the results of the new car. So for Formula One to deliver on its future vision, it must engage the right partner. And when we talk about technology and when we talk about cloud services and analytics and machine learning, AWS is that partner.
What a great example of how machine learning capabilities are driving innovation in impactful ways. So ML can enhance customer experiences, boost employee productivity, cut costs, reduce fraud, and more. It's helping organizations tackle their biggest challenges. At AWS, we have the most complete and broadest set of machine learning capabilities. And whatever your experience level in building AI and ML services or using AI and ML, we have services which will help you get value and build applications. So for experts, which are your data scientists and they know how to build these models, we have optimized versions of frameworks like PyTorch, MXNet, and TensorFlow. And we've got the best choice of compute, networking, and storage infrastructure so that you're able to build your ML services yourself. For the next kind of user who wants to build, who wants to maybe use a more managed service, we have things like SageMaker. And this is for developers and data scientists. I like this service because it's a service that I can use myself. Like, I've never really built an ML model, but I was able to use SageMaker to build ML models and start exploring how we could start using machine learning myself. And it's something I never thought as a developer I would be able to do. It always felt like some fanciful thing in the future. With Amazon SageMaker, it enables developers and data scientists to really start building their own machine learning applications and models. As I say, it's something that I can use as a developer. It's something that I'm able to kind of start using and start getting value from my data. It removes a lot of the complexity of machine learning. It allows you to sort of start experimenting and training, and you can deploy your models to the cloud and start building your own custom machine learning models and deploying them so that your customers can use them inside your applications. So these AI services allow you to use these AI services to do things like computer vision, for image recognition, for video recognition, for speech, natural language understanding, personalization, or highly accurate enterprise search. And you're able to implement these APIs into your applications simply as an API call by using APIs. Any developer here can use a RESTful API, and then we can start implementing machine learning into our applications using AI. Really, with these resources and these services, machine learning is becoming accessible to all builders. Builders can build on top of these services to create innovations of their own. But if you're not a machine learning developer and you've never done it before, it's difficult to get started. And education is crucial to enabling machine learning and enabling us to take advantage of machine learning. And that's why Amazon's committed to train 29 million people by 2025. And ML education is a big part of this. We've got a wide variety of formats for learners through the Amazon Machine Learning University. One of my favorite things is getting really hands-on with the technology. And one of the best ways that you get hands-on with machine learning is through the Deep Racer League. To see what we're doing with Deep Racer, let's check out the latest in this year's 2022 Deep Racer League.
Hi everyone, I'm Ryan Marine, and I'm excited to bring you the next evolution in racing, the world's first global autonomous racing league, AWS Deep Racer. Since launch, over 140,000 developers from more than 150 countries have participated. And this year, the Deep Racer League is more accessible than ever before. With the all-new Student League presented by Intel, high school and college students worldwide can compete for scholarships, prizes, and glory. Students can get rolling with just a few clicks, no credit card required. All new AWS Deep Racer arcades will let you skip the coding, grab the wheel, and race head-to-head against AI. Compete from anywhere in the world in monthly virtual circuit races. And the Summit Circuit is back in person on physical tracks across the globe with more chances to qualify for one of 50 coveted spots in the championships at reInvent. Discover how you can accelerate your machine learning journey at deepracerleague.com.
Now, the thing that I really love about AWS isn't the services and the features, it's the customers which build on top of those services and features. We have incredible, innovative customers. And I'd like to introduce a customer now. He's an AWS data hero and has built nearly a dozen cloud-native data platforms on AWS, ranging from data warehouses and data lakes to real-time activation platforms. Please welcome Elliot Cordo, Head of Data at Capsule.
Thanks, Martin. Good morning, all. It's really great to be here today in real life. I'd say that I'm living the dream being here today. And I'm here to talk about Capsule. So Capsule is a New York City startup that is set out to build, simply put, a pharmacy that works for everyone. So pharmacy is a $425 billion industry. And just 2% of this industry has been digitized in any way. In fact, conventional pharmacy continues to operate with pretty much the same model as it started. This is a model that's over 100 years old. It's also one of the most frequent healthcare touch points, with 70% of the US population interacting with a pharmacy at least once a month. This is far more often than they see their doctors. Unfortunately, the average wait time for a prescription in pharmacy is around 60 minutes, which is fairly at odds with the modern consumer experience and definitely not what you want to have when you're feeling unwell. Out-of-stock rates are around 40%, compounding customer frustration when they find out they can't get the medication they need. And this results in what I found to be a pretty startling fact, that 1 in 2 prescriptions are never picked up. So that means that half of the time, people are not getting the meds that they need to feel better. So obviously there's a huge opportunity here, and that's where Capsule comes in. We deliver prescriptions the same day for free. We manage customers' refills so they never run out of their medications. And we have pharmacists available to chat by phone and text 7 days a week. So you can have a private conversation about your health and your medications without having to have it in a public place like a pharmacy counter. And this has yielded results. Capsule customers are 50% more likely to get their medications than a conventional pharmacy, which is better for the patients and also better for the doctors. We have a 5-star app rating and consistently top-ranked pharmacy in all of the markets that we exist. So how do we do this? One way is right and fast, which is a core operating principle at Capsule. And it's how we think about approaching our work as well as looking after our customers. Right and fast can be considered opposing forces, but we feel they can work together when enabled by simplicity, reusability, and automation. Right and fast has supported our evolution from a small startup to an advanced microservice platform at national scale. It's enabled us to iterate quickly, conducting experiments and being data-driven. Leveraging AWS has been key to the removal of our infrastructure concerns, value-added services that help us to go right and fast. And we've been growing a lot. COVID-19 really supercharged digital healthcare. Capsule saw this in a few ways, and luckily we were able to scale our offering because of AWS. We had hyper growth in our original New York City market, where customers didn't feel comfortable leaving their homes to get their much-needed medications. And expansion into new markets. In 2020, we expanded to Boston, Minneapolis, Austin, and Chicago. And today, we're in more than 24 markets, which gives us the potential reach more than 100 million Americans. We've been enabled by AWS to elastically scale to enable this expansion, be right and fast in introducing new product features, and support the microservice decomposition of our platform, essentially changing the engine while flying the plane. Capsule is an extremely data-driven company. And to be data-driven, you need to be both accurate and timely with data, to be fast and right. So we've been focused on what we call day one analytics, which may resonate with some of you, which is the idea that when you build a product or a product feature, that you are able to perform analytics on it when it launches, so you can make data-driven decisions. And also shortening the time between these initial insights and more robust insights and analytics. So we're solving for this by implementing an event-driven architecture. So we're leveraging AWS managed services such as Kafka, Kafka Connect, and the Glue Schema Registry to seamlessly collect all of our business events into a data lake, and Spectrum to make this data available to our consumers. This solution provides us a well-governed, reliable, and consistent pipeline where we're able to onboard new data from new products, new services with very little configuration. This helps us to enable day one analytics. We're also focused on leveraging machine learning to provide our customers a delightful experience. Such use cases include speeding up automation by removing manual steps required to successfully submit a claim. By removing these roadblocks and kind of this impedance, we're able to get prescriptions in the hands of our customers that much quicker. We're also using ML to predict customer refills, like when they're going to need refills on their medication, so we can retrieve their medications proactively without them ever having to ask. This has all been enabled by SageMaker. This provides us like a one-stop shop for machine learning workflow without having to worry about the concerns of machine learning infrastructure. Starting with the data science environment, the notebook environment, through the ability to train and deploy models at scale. This enabled us to implement our first end-to-end pipeline in just a matter of weeks. Again, simplicity and automation, allowing us to move right and fast for our customers. So I'm really excited about what's ahead for us, and we'll be continued focus on making healthcare as seamless and simplified as possible, and creating a platform which provides our customers a delightful experience, and our partners in the healthcare ecosystem benefits as well, especially our doctors. And operating fast and right, growing to provide support to 70% of the US population in a very short time. So in closing, we should challenge ourselves, how can we all build right and fast? For us, this has meant focusing on simplicity, automation and reusability, and leveraging AWS. Thank you.
Thank you so much, Elliot. It's great to see how Capsule is using the power of data and machine learning to build faster, simplify, and automate, creating better solutions for anyone who needs a pharmacy. Now, machine learning is being applied across all industries. And my favorite use of ML is when it helps people do their job better. An example that Werner often talks about is in radiology. Now, you all know Werner as a computer scientist, working for Amazon, building innovative systems for Amazon.com. But before Werner became a computer scientist, he was actually in radiology. And this is a picture of Werner. He's the person there on the left, in the clogs. And he always tells me a story of the power of ML and how it can be used for good. And he uses radiology as an example. You see, radiology requires a lot of, when he was involved in this, it requires a lot of analyzing images and data and storing that data in archives to be able to examine it and to use it. And most medical there's requirements to keep that data for up to 30 years, that medical information. Now, when you're looking through this data, you're having to be, you're having to look at it extraordinarily carefully and use a lot of brain power to do that. And it takes a lot of energy. And he tells me of stories, they'd be up at 10 p.m. at night looking through this data and analyzing it, trying to do the best for their patients. And really struggling, your eyes are tired, you might be missing things. And this is really where ML can kind of augment humans, help them deal with some of these more difficult sort of scenarios. Not replacing the human, but augmenting them to make better decisions, helping them with their job. Machine learning is also having a huge impact in the industry I work in the software industry. Applications have become increasingly distributed. Developers need to more automated processes. We have to think about DevOps. We're having to manage these large distributed systems. And we're collecting a lot of information about these operations, though, as well. Lots of data, metrics, logs, all those sorts of things. And because of that amount of data, we can start looking upon DevOps as kind of a data science problem. We can start using ML to free builders from the mundane parts of the job, to augment them, to help them build more reliable, more resilient systems. And services like Amazon DevOps Guru does just that. It allows software operators to more efficiently prevent and remediate outages in production. And they're constantly innovating too, and they've got this new launch which is in GA today, which is Log Anomaly Detection and Recommendations, and I'm excited to announce it's in GA today. So this new feature shows targeted recommendations to resolve the anomalies found in logs. Now, before the console in Amazon DevOps Guru, it displayed the metrics and it shows you a timeline of when an application anomaly took place. But this new feature, it displays the contextualized information around that anomaly and allows you to deep link into the right section of CloudWatch so that you can remediate the problem more quickly. It's supporting you in your job. It's using machine learning to find these anomalies, to find problems before maybe even they happen, and help you remediate your systems and run more reliable systems. And it's not just helping operators, it's also helping people building software. Now, software development is an extremely creative process. But it does contain lots of repetitive tasks as well. And CodeGuru is kind of helping software developers augment their abilities to help them be more effective. There's two kind of components of CodeGuru. We have the reviewer, and this detects potential defects that are difficult to find in your code. So when you're checking in code, it can do like a code review for you with machine learning, and offer suggestions and improvements to your code. And these ML models that we built to power CodeGuru, it's been trained on millions of code reviews that we do at Amazon and the huge amount of data and experience that we have of running large software applications. We also have CodeGuru Profiler, which is a profiler which runs alongside your applications, and it can profile our applications at runtime and provide visualizations and recommendations to help you fine-tune your application and fine-tune the performance, and also find expensive lines of code inside of your application. Now, these services are great, but we can do more. ML can help augment software developers and help them remove some of the undifferentiated heavy lifting that they have to do in their jobs. And if you think about when you're writing software, you have a problem that you're trying to solve, and you might want to read around documentation to figure out how to solve that problem. You often end up writing code that you've written 1,000 times before. I've certainly connected to a SQL database from an application probably more times than is healthy in my life. You're looking and hunting around for ways of doing things, going on websites, finding code snippets of information. Someone else has done something before, copying that code and pasting it into your application. It might be in a different language. It might not be in your C# or Java or Python or whatever you prefer. So you might have to do this mental thing of the mental work of transferring that to the language of choice that you have, find the right frameworks that you could use. All that kind of stuff, which we do as software developers, but really, it's not the core thing you do as a software developer. The core thing, the value you provide is really solving the problems in a unique way. It's not all of the stuff which sits around it. And that's why we built Amazon Code Whisperer. Now, Amazon Code Whisperer is something which lives inside your IDE and can help you as you kind of develop your software. It's using ML to augment the development process. Developers can simply write a comment that outlines a specific task in plain English inside the IDE, such as upload a file to S3, and a code snippet is recommended directly in the IDE in real time. It can generate code recommendations that are several lines long, even entire functions inside of your application. It currently supports Java, Python, and JavaScript, and a number of different IDEs, including IntelliJ, PyCharm, WebStorm, VS Code, Cloud9, and it's also embedded inside of the Lambda console as well. Now, I think Code Whisperer will really help boost developer productivity, but it's essential to harness this power in a responsible manner. There's a lot of messy code in the world, and when we train these models on open source projects and projects at Amazon, and there's probably code in there which is not necessarily the best examples of code. And so when we were building this system, we had to think about how we would tidy up some of those things, how we could improve some of those things. Because in that code, there can sometimes be bias, there can be secrets which are embedded in the code, or there can be general security flaws maybe in that code. So we've incorporated capabilities that mitigate these risks, such as security scanning, which can detect vulnerabilities in your developer project and give you real-time inside of the IDE recommendations of security issues. We also have a feature, a reference tracker, that detects whether the source code that we're recommending to you might be similar to something which is from our training data set. So it gives you the option to then decide whether or not you want to use it. You might be recommended a snippet, which we think is very close to an open source version, and we will tell you the project where that piece of code comes from and the license that that project then has, so that you get to make the decision as to whether or not you should include that snippet in your code, or maybe you should invent something yourself. And also, Code Whisperer empowers you to avoid bias by removing code recommendations that may be considered biased or unfair. So Code Whisperer is really fun. It's really awesome. I encourage you to try it. There is opportunity to try it here at the summit today. But I encourage you to go out, sign up for the preview, and try it for yourself. Now, SDKs, frameworks, toolkits, they enable developers to be more efficient, but they're kind of incremental. They're minor when you compare them to the impact that machine learning is going to have on software development. ML is really laying the foundations for what will become the future of software development. And services like Amazon DevOps Guru, Amazon Code Guru, and Code Whisperer are really the first steps in what I see as the future of software development. The cloud has changed how we build applications. Everything's become a programmable resource. You can scale up things without having to buy more hardware. Capacity is now just a click of a button. Machine learning services you can just access at will. The ability to switch things off with ease when you're not using them, to scale things down, that allows you to not only be more cost efficient, but also more sustainable. You can actually switch things off. You don't have to use things constantly. And you can start to build things that would have been previously impossible. AWS provides you with the broadest and deepest set of services, and we're constantly innovating on your behalf, unlocking new capabilities and new possibilities. It now means that AWS can be used for any type of application. Mission-critical applications, applications that require low latency, any kind of application you can imagine can be built on AWS using our services. And once you move to AWS, you're going to be in the perfect position to build a data strategy so you can make faster, higher quality decisions with your data. Now, I've talked about a lot of things today, but I encourage you to explore them in the summit today. Head over to the expo hall, where we have things like the Deep Racer competition, where you can try out that Deep Racer car, the Dev Lounge, and the Partner Theater, and attend some of the breakout sessions that we have here today. I encourage you to really switch off your phones, don't answer email today, and learn and be curious. Take this day to really explore AWS. There's lots to learn, and as Werner would say, now go build. Thank you very much.